Ah, those soothing words. Okay. So thank you so much, everyone, for joining us. Welcome to this meeting with our special guest, David MacMillan. David, thank you so much for coming this evening. My name is Kathy Nasati, and I'm a member of Toronto East End Climate Collective, or TEAC. First, I want to begin with a version of a land acknowledgement. I want to give you two landmarks, two links that I would hope that you will consider taking a look at. The first is Bob Joseph being interviewed about his book, 21 Things You May Not Know About the Indian Act. This interview was done about 5 years ago on TVO. And if you're not familiar with that book, this is a very good way to learn a bit about it. And the second one is a website of Dr. Pam Palmater, a Mi'kmaq lawyer, author, and activist, a really extraordinary scholar and person. And she also has 3 different podcasts that you may want to take a listen to. So with respect, I encourage you to listen. So now I welcome you again on behalf of TEAC, Toronto East End Climate Collective. We're very happy to have David here from the City of Toronto to speak to us about thermal energy networks for buildings. This is our second event in our speaker series on district energy. So now I would like to invite Kyle to step in and continue. Thank you.
Thank you, Kathy. So I'm just going to give you a little bit of a background about TEAC and this series, and then introduce David MacMillan. So TEAC is a small core group with a membership of a few hundred. We try to understand the causes of the climate crisis and then advocate both locally and nationally for constructive responses. In Toronto, buildings are the largest source of greenhouse gas. The choices we make in heating and cooling these buildings play a pivotal role in addressing the climate crisis. TEAC discovered that if Toronto tries to heat and cool its 400,000 plus buildings with air source heat pumps alone, it will need to generate much more electricity and expand the grid to carry it. Both the Boltzmann Institute and the Independent Electricity System Operator predict that the result will be an enormous electricity demand at an enormous cost. In comparison, thermal energy networks, often called district energy, use much less electricity. This is why TEAC is mounting this series of speakers to learn more about thermal energy networks and to see if we can use what we learned to make thermal energy networks more popular as a way to heat and cool buildings. This led us to invite David MacMillan to speak with us tonight, and we were delighted when he accepted. He's already been a huge help to us in planning this series. He will talk about the basics of thermal energy networks using examples from right here in Toronto, and then he will discuss the potential for influence and funding on the future of thermal energy networks. In a moment, I will introduce him, but first a bit of housekeeping. As Kathy said, we're recording the meeting and we're going to post it on our TEAC YouTube channel. And we're going to ask all of the attendees please to stay muted. David MacMillan will speak for approximately 30 minutes, and then there'll be a Q&A until 8:30. We're going to use the Zoom chat, so please feel free to type your questions into the chat prefaced by the letter Q, and Rose, our chat moderator, will voice your questions to David. And now some background about David. He is a program manager with the City of Toronto's Environment and Climate Division, where he is focused on planning for low-carbon development and energy systems for more than 10 years. He works closely with internal partners and the development industry to achieve net zero emissions buildings. Currently, he's focused on delivering mass timber affordable housing and creating online platforms to help energy developers leverage city-owned assets for renewable thermal energy projects. David holds a Master in Environmental Studies from York University and is a graduate of the ULI Toronto Kirtner Urban Leadership Program. Now, in a moment, I'm going to turn this event over to David, but first, let's watch a short video by the International District Energy Association. How's it going, Don?
District energy is a vital solution to decarbonize energy systems for cities, communities, and campuses. Around the world, investments in district energy infrastructure are accelerating the shift to lower carbon solutions. Among the first environmental strategies deployed by cities, district energy displaced hundreds of individual coal boilers in buildings, making the air cleaner for citizens and buildings safer and easier to operate and manage. Over time, district energy systems have evolved to leverage new technologies like industrial heat pumps, CHP, geothermal, energy sharing, and a wide range of renewable resources. District energy systems are flexible, reliable, and resilient, and by aggregating the energy needs of hundreds of buildings, they achieve economies of scale for cleaner, lower carbon solutions. Often, district energy connects to the power grid at transmission level, allowing access to cheaper wholesale renewable electricity, which enables customers to more easily decarbonize while avoiding the risks of unproductive, expensive building HVAC retrofits. District energy, we're built for this. For more information, visit www.districtenergy.org.
Thanks. And now, everyone, I'm going to turn the meeting over to David MacMillan. Hi, David.
Thanks so much. Thank you. You can hear me okay?
Yep.
Yes, I can hear you.
Great. I'm just going to share my screen. Give me one sec here. You seeing my my presentation?
Yep.
Perfect. Okay. Yeah, thanks. I tough to follow that video because now you got to see my City of Toronto bureaucratic graphics, which are not quite as nice, but I'll do my best to get through it. So hi everybody, David MacMillan with the Environment and Climate Division. Don and company asked me today to speak to you about thermal energy networks, which we'll get into what those are, but you might have heard of district energy systems, the thermal grid. There's a bunch of different names for it, but really they all mean sort of the same thing. And so I'll go through what that looks like. I'll share some examples, and then at the end we'll have lots of time for Q&A. So first of all, what are we talking about when we say thermal energy network? There's a gentleman that I like to reference for this question. His name is Bruce Ander, and he's the CEO of Markham District Energy. And he often calls it the thermal grid, or the third grid, basically after natural gas and electricity. And he also says that it's really not a technology, but it's really a platform for other technologies. And it's much more, you can think of it a lot more like infrastructure. And I like these two images because on the right, you have is an image of a still functioning district energy system that's like, 700 years old. And that shows you, juxtaposed to the one on the left, it's really just the distribution of hot water, chilled water, some kind of medium for heating and cooling. Obviously, in the 1300s, they didn't have high density polyethylene, so they were using wooden pipes, but they captured hot spring water and distributed it to homes, and they heated space with it. And it's basically done the same way with better equipment, different materials, and I would say renewables. But this old one actually here was essentially it's a hot spring, it's geothermal. So it's always been renewable, and we're just trying to bring it back now. But the point is to think of this as infrastructure, and that's important because the way we plan for infrastructure is different than doing things sort of at a smaller scale, and there's different implications for that, and I'll get into it. But first, some context. You're probably all familiar with this by now, but we do have a very ambitious goal to decarbonize, the City of Toronto by 2040. And really what that means is, because we have a fairly clean electricity grid, heat pumps are going to do most of the work to displace natural gas. And we can do that at the building scale or the district scales we'll talk about. Really, the question is, what do you couple it to? And off the top, we heard about air source heat pumps. There are so many options for low carbon thermal energy, and I'll go through some of them. And there are pros and cons to each. The point is, a heat pump plus a low carbon thermal energy source is really how we're going to displace natural gas use, which is the largest source of our emissions. Basically, it's 90% of the emissions from buildings, which makes up almost 60% of our total. That graphic's a little outdated. It is closer to 60% now. So just electricity is going to underpin a lot of our decarbonization, and so for that reason, we're working closely with Toronto Hydro, and of course, and thank you, Don, for your deputation at council today. We need to continue advocating to the province to say that we need to keep the grid clean, and there's a lot of work to do there. But I do appreciate that advocacy. Just in terms of the broad opportunity, this is a node scan we did in 2012, actually before I started the city. It's really nothing earth-shattering, but it shows that there's opportunities for thermal energy networks across the city. And it generally lines up with areas of growth, which in Toronto, that's a lot of areas. So that's number one. Growth is really what drives district energy. We also have a lot of existing systems. Toronto's got an older downtown, a lot of older campuses. And so those areas happen to have thermal networks that can either be expanded or fuel switched. And when I get to the examples, you'll see what I mean. But again, we also have those aggressive targets for decarbonization, and district energy can play a big role in that because you can achieve things at scale that are otherwise too expensive at the building scale. So what's our approach? It's important to understand that thermal energy supply, district or otherwise, is not regulated by the Ontario Energy Board, unlike electricity and natural gas distribution. Basically, if you want to start up a geo exchange company, you don't have to go to the OEB every year or every 5 years to get your rates approved. It's all done on contract basis, customer to provider. And we as the city, we don't have the authority right now to mandate connection on private property, which is also important because there are jurisdictions in Canada that can do that, and they do use that to their advantage. So we have some challenges, I would say, for scaling district energy, but the approach we've taken really, I think, it reflects that, but it's been fairly successful. So what we do is we regulate what we can. We lead by example with our own assets, which we have a lot of. And of course, we have to enable the private sector to essentially, we have to partner with them and so enable them to do their job where they want to deploy district energy. So one of the first ways we regulate is through building approvals. So at the early stages, when an applicant's coming in for rezoning, if they're over a certain size, we essentially tell them, go talk to a district energy developer. 1 million square feet is about our threshold, which depending on your business model, could be a little bit small. But bottom line is the larger you get, the more, the better opportunity there likely is for district energy. But then where things really pick up is with the Toronto Green Standard at site plan approval, because it's driving decarbonization through essentially a carbon target, and the goal now is net zero new development by 2028. That's forcing developers to think very carefully about how they're going to decarbonize for their new development. And so this is important because it doesn't say that you must use district energy. It doesn't specify any technologies, but because it sets a performance goal in terms of carbon and energy use, that will require to screen certain technologies, but also consider value-added opportunities like working with energy developers on a district energy system. In terms of incentives, we don't have a lot we definitely don't have a lot of financial incentives. We do have some financing programs that we can use, but there are a lot of opportunities for non-financial incentives to, basically work with applicants, try and get them to do better than the minimum. And in some cases, it works really well with thermal energy solutions. So one thing we've done is through zoning bylaws, you can actually allow developers to repurpose, essentially reuse the space that they save in their mechanical penthouse when they're using a low carbon thermal energy source. So whether they're connected to a thermal energy network or using on-site geo-exchange or wastewater, that gets rid of equipment that typically would be in the penthouse. So you may not need a cooling tower, you may not need any boilers. So now all of a sudden you have all this space. Well, through a simple change to the zoning language, developers can repurpose that, and that's a lot of value. That's penthouse space in Toronto. That pays for a lot. And so we've done it now on maybe 10 projects. No cash changes hand. The building's not any taller. It just essentially there's more units, and so it's a nice win-win that we've been able to unlock with our colleagues in city planning. But like I said, the other thing we do is we enable access. The city owns a lot of infrastructure, but also we can go and do things, spending some limited dollars to provide information to the industry that they would otherwise have to spend a lot of time and effort to collect. So the image you see there is a map of the sewer system in Toronto, the larger trunk sewers. And we spent some money and hired a consultant and worked with them to essentially map out the heat that's available in the trunk sewer network. There's a lot of it. Toronto's a big city, and some catchments obviously have more than others. The point is, like, no energy developer would do this work. They would look project by project, but for us at the city, we can sort of leverage our team and the resources we have to provide this information at no cost. In fact, it's on a public website now where anybody can go in and find out how much heat is available in the trunk sewer next to their proposal. And so we have, I think, over 20 inquiries already for projects. We have quite the pipeline built up. This is something that, for relatively low cost, provides a lot of value because it will help developers sort of move past that first hurdle, which is gathering the data. So this is not the only thing we're working on. We're working on a program for shallow lake heat exchange, same idea. We're working on a program for opportunities for open loop geo exchange, a little bit different than the typical closed loop systems, and we can talk about that in the Q&A perhaps. The point is, information is very valuable to the industry, and we can reduce the burden to get that, especially in the case of sewer where we own the infrastructure. So that leads into the category of leading by example, where we actually now, besides providing the information, in some cases we have to get directly involved with projects. So on the far left there, because we own the sewers, obviously we're a key partner in these projects to actually use wastewater to heat and cool buildings. And so that image there is of the wet well shaft where the private energy developer Noventa is going to essentially take heat from the sewer and feed Toronto Western Hospital, which you see in the background there. That project is going to reduce emissions at Toronto Western Hospital by 90%. And you know, a hospital is a major energy user, major emitter. This is a massive project that it will expand, and there are many other opportunities, like I said, in the pipeline. In the middle is the first lake-based heat exchange project that the city did. This is different than deep lake, which we'll talk about. This is shallow. This is where a heat exchanger essentially goes in one of the slips. And it's that size you see there is basically to decarbonize the waterfront neighborhood center, so one large building. But of course, we have a large waterfront too, and this can be scaled where the opportunities present themselves. You know, we don't necessarily own all of the waterfront, but we do own a lot of the land, not necessarily the water itself. So we're a key partner, though, in working with Port Authority and others to deploy this technology. And then lastly, in the Portlands, where we have both ambitious growth targets and ambitious decarbonization targets, we're looking at sort of the big idea. And in this case, what we're looking to do is deep geothermal. You know, the terms get used a lot and often incorrectly. Geo-exchange is where the earth is used as a battery, and that's where the holes are, you know, up to 850 feet deep, typically. In the case of deep geothermal, we're actually extracting heat from well below the surface. The test hole alone that we need to drill is 2 kilometers. The final holes can be anywhere 7 to 10 kilometers. We're talking oil and gas type drilling. Capital costs much higher, but a lot more energy because you're going so deep. But the Portlands, because of the decarbonization goals, because of the growth targets, because of the challenges with electricity infrastructure, there's actually potentially a lot of value in exploring that. And so this is the kind of things that we do as a city, where we can do the test hole, we can provide the information to the industry so that they can then do the projects. So we play a nice role, and we found a nice niche in that space there. So I'm going to just go into some of the examples now of some of the projects, and I'm mostly just showing pictures. I'll talk through it, and then before I share the presentation, I'll include a lot of links, and that way, if you want to do further reading, you can. This is Exhibition Place, and the image on the left, what you're looking at is Hotel X. I don't know if any of you have been there, but it's a pretty swanky hotel. It was built a few years ago, and it was essentially an opportunity for us to develop our first district energy system. The image on the right there, you can see the hotel under construction in the background. The open cut there in the boulevard are the pipes that are going underneath Princess Boulevard to connect the hotel to the Enercare Center. So district energy is as simple as pipes connecting, you know, in that case, a new hotel to the Enercare Center where the central plant is. This was a very modest project, all natural gas based, but we are creating here the thermal network that is going to allow us to fuel switch, hopefully in the near future. And so this is kind of what district energy can look like in its most basic form. And it's hard to see from the image here, but just in the foreground of the Intercare Center, you can see a patch of asphalt that's darker than the others. That's where those pipes were installed into the right of way. So at the end of the day, district energy looks like nothing. You don't see any of it. And that's kind of part of the value of it, frankly. It's hidden, which is why we do a lot of tours, but ultimately again, it's like infrastructure, blends in with the urban fabric. On the right there, those are the district energy pipes being run through the parking garage of X Place. And the huge advantage of not having to dig and install pipes, but that's kind of what the infrastructure really looks like. Now, you've probably all heard of deep lake water cooling, and these are, two of well, for me anyways, iconic photos. These are about 20 years apart, and what they show is these tugboats basically pulling out the deep lake water cooling intake lines from the downtown out into the lake. On the left is the first one, which was back in the early 2000s. On the right, just last year, I believe, or the year before, which is the expansion of the deep lake water cooling system. And here you see how it works. Essentially, the pipes are about 5 kilometers out into the lake, and at that distance, Lake Ontario gets deep very quick. It's about 83 meters deep. And so they're drawing water at 4 degrees Celsius, which is actually too cold to drink. Toronto Water would actually in the past have to warm it up. Long story short, Toronto Water needed new intake pipes, and we essentially, the city was involved in creating Enwave to solve 2 problems at once. Getting new infrastructure for drinking water and also creating this district energy company. And so essentially what happens is, that there's a loop that feeds buildings in the downtown core. And as they reject heat, primarily commercial buildings, that heat actually warms up that colder water. And that's where we get our drinking water from. And so Toronto Water has to spend no energy warming it up. So it's actually palatable for all of us to drink. And the buildings get this cooling that would otherwise be essentially wasted. And no hot water goes back to the lake. Again, we drink all of this. So it's a really nice, it's very geographic. Not every lake is suitable. Not every city has a downtown close to a lake, but we took advantage of it many years ago. And maybe one day you'll get to do a tour, but this is the sort of the pièce de résistance in inside the John Street pumping station on the right, the row of heat exchangers. It's dead silent. It's nice and cool on a hot summer day. That's another version of district energy. Again, it's pipes and heat exchangers, pretty basic stuff. But off the top, we heard about electrical demand. The current size of deep lake water cooling shaves about 60 megawatts of peak demand from the downtown by essentially offsetting air conditioning load. So these kinds of things can be very powerful, both in terms of decarbonization and demand reduction. Regent Park is another one you might have heard of. The photo on the left there, I like it for a few reasons, but the thing to focus on is that at the very top, that little plume of steam, that is the only plume of steam you'll see at Regent Park. If you look around almost any other part of the city, every building has steam coming out of the top of it. Essentially, it's exhaust from the boilers. At Regent Park, that's the only one you'll see because all of the equipment is centralized in the district energy, the energy center, which is shown on the right there. And in another format, I'd love to show you sort of a video of it, but no one would ever know that it's there. In fact, people living in the building where this energy center is have no idea there's a plant underneath them. And so there's nothing, this is a gas-based system with a plan for fuel switching. But the point is, this infrastructure is below grade in an urban setting that minimizes both impact at the rooftop, but also, you would never know there's a massive energy plant below what is feeding sort of millions of square feet of mixed-use development. But what's really interesting about Regent Park is phases 4 and 5, which are recently awarded and starting to come to fruition. The photo on the left shows the juxtaposition between old and new, and really the old is you're looking at how it exists today and soon to be demolished. But if you look at the center of that image, there's an old smokestack there. That was the original coal-fired energy center for Regent Park. Regent Park had a thermal network back when it was built in the 40s, and again, the technology is it's pipes, right? But at that time, it was coal. And the reason it made sense is because you cannot efficiently deliver coal to that many buildings. Much more efficient to drop it off at one spot and burn it there. And so that smokestack is still there. And if you look at the image on the right, it basically says that you're going to see that building repurposed in some kind of community hub. So the cool thing about infrastructure, it can be reused and repurposed, reimagined in new ways. And I didn't get into it here. I don't get into it in these slides, but there is an ambitious plan to decarbonize all of Regent Park that's emerging. And the only reason we'll be able to do that cost effectively with TCH is because of the thermal network that is now serving all of the first 3 phases and will serve phases 4 and 5. And one day I'd love to present to you about what that looks like. It's too early to share anything, but I think it's going to be a great story for the city when you think about decarbonizing millions of square feet in one shot. And so one day I'd like to share that. This is the most recent one I've been able to work on, which is the Etobicoke Civic Center precinct. So this is at the intersection of Bloor, Dundas, and Kipling. Essentially the new downtown of Etobicoke. This is all city-owned land that was unlocked when we basically redid all the roads around that intersection, brought it up to grade, and unlocked about 14 acres of development. And the plan, which is now coming forward, the contract was just awarded for the image on the right. That's the Etobicoke Civic Center, the new civic center for city staff and for the community. Office towers sort of at the top, and basically all the sort of community center space, library, recreation space at grade. What you don't see basically is that civic center has 2 parking levels below grade where we worked with Enwave to put in a 30,000 square foot energy center. It's going to be geo-exchange based, and it's going to serve all 3 million square feet of housing, much of which will be affordable, surrounding the civic center. So we, the city, put up our own space. We're charging a lease, of course, but we are hosting the energy center that will feed all of the development and will feed our building as well. And because of that, these buildings will use virtually no natural gas. The only source of natural gas use in the whole development there will be for the backup power generation, which is virtually a negligible load. And so this is what we call typically our first sort of net zero community. This is what, on the left, is what it looks like. When I rode by there several months ago, they were drilling the geo-exchange holes, and you can see some of the existing buildings in the background. Construction's happening. And on the right is the first block of housing that will be developed, which is soon to get underway with construction. So it's actually happening, and this has been, probably more than 10 years in the making, which one of the downsides of infrastructure, it can move slowly, but the effects are big. So we're really excited about this project. The last example I want to share with you is, I'm sure you know of Enwave. I've already talked about it a little bit, but they don't just operate a cooling system, they also operate a heating system. And so they are rapidly expanding, or trying to rapidly expand both of those. The image on the left there shows their expansion to the west. You might have heard of the Well development. That anchored their huge western expansion. And then the yellow bars pointing eastward along the waterfront, those will that's the start of their eastern expansion, which is well underway. But what's really cool, like this district energy system you hear, the pipes you see there are decades old. But because of them, Enwave, what you're looking on the right is their Pearl Street Energy Center. At that energy center, they can fuel switch there and start to decarbonize the entire system. So they got funding from various levels of government, and they are currently under construction with a large addition to the plant to install an industrial air source heat pump. They can start to basically produce high temperature hot water, maybe even steam. And without making any changes to their customers' buildings, they can start to reduce their emissions. Imagine having to go to all of the different hospital buildings, all the different financial tower buildings, and start doing retrofits there. Very complicated. Enwave and the thermal network allows them to decarbonize at scale. And I talked about these a little bit, but at the well, there's a massive underground storage tank. This is now, like what you're looking at here is not grade. That's 6 stories below, 6 parking levels below grade. Massive thermal storage tank that will allow them to continue expanding their system to the west. On the right, there is sort of a rendering of what we think Villiers Island is going to look like. That's what we're trying to get to with Enwave to the east. A lot of growth coming, and it's meant to be a climate positive community. So if we can get there, I mean, we are going to need a thermal network, I think, to achieve that in a cost-effective way, rather than trying to decarbonize each building individually. I'll go quickly through. I have, I think, 5 or 6 more slides, but again, this is more something that feel free to look at afterwards. But I want to touch on policy a little bit, and this is work we had commissioned probably 10 years ago. Essentially, there are different sort of categories of policy, and Toronto is what I would say DE moderate to, so district energy moderate, trending towards district energy light. The district energy sort of aggressive category, there are jurisdictions that do that. As I said off the top, where we don't have the authority to mandate connection, where we don't have regulation of thermal energy in Ontario, our approach has been to a pretty light touch. We have we regulate buildings, like I said, but we are not so aggressive on the construction of systems. We work with the private sector to enable that, which is why I say we're in the moderate to light. Our policies are more to enable, and then where there is a role for us to play, of course, we get involved. But on the far right of that diagram, again, there are jurisdictions that do that, and we can talk about that in the Q&A, but that is probably not Toronto's path. I think I just want to say that because you've seen all the examples, of which there's only a handful of the activity in the city. You don't need to be DE aggressive necessarily to enable district energy. One of the things that often can be a bit of a stumbling block to getting in aggressive with district energy is ownership, because with ownership, with control comes risk. District energy is capital intensive, it's slow, there's risk that, and we've seen in other jurisdictions that if things fail, it can be very, very challenging. And so our city councils made the decision not to be in that business, but to enable others to do it. The point of this graphic is that there's a spectrum of models from 100% public to 100% private. The city is, depending on the system, somewhere in between. I don't think we'll be 100% public. And where there are 100% private, it's not to say we played no role, it's just we don't own the system. We're not responsible for the day-to-day, and we're not receiving any revenue from the operations of that system per se. So this is what the ownership looks like of some of the examples that I went through. Exhibition Place has its own, obviously, board that the city constitutes. So it's kind of like a quasi-city project, but it's really X-Place Board of Governors that owns and operates it. Enwave has been through a variety of sort of ownership states. Started with, it was city-owned back when it started, I think, in the 60s. These days, it's owned by pension funds because there's a lot of value in it. And for pension funds who are patient, it makes a lot of sense to get into sort of the utility business. Regent Park started as a JV, and now it's entirely owned by Toronto Community Housing. The Etobicoke Civic Center precinct, again, our land, our buildings, so we are leasing space, but it's owned and operated by Enwave, a private business. Just want to make it clear as well that it's not just in Toronto. There's a lot of activity in the greater Toronto area in district energy, and what you see there, our top left is a project by Minto in Oakville with Creative Energy doing the district energy system there. Bottom left, also Creative Energy project where they're going to use wastewater energy for, this is in Whitby. Top right is Lakeview in Mississauga, big development by the waterfront, again, a wastewater energy project. Bottom right there is it's a project in Markham where it's actually district energy for homes, and we'll talk about that sort of at the end, or for houses, I should say. All of these really are, they're mostly low carbon because these are new systems, and they're largely privately owned, operated with, of course, municipal involvement. All of them tend to use this energy developer business model, which is really important for the discussion probably when we'll have about small scale systems. Again, there's no rate base for these utilities. It's all done on contracts from supplier to customer. The model is based on the value they offer is that they can avoid sort of the cost of installing equipment in new buildings, and they earn their revenue through energy sales. So they are able to compete with conventional utilities by, one, avoiding capital, and then being able to guarantee certain rates over time. Longer agreements are better, but typically in the 20 to 25-year range. What they do ultimately is shift capital to operating. So there's savings up front, and essentially you pay what you would otherwise pay over time. The reason renewables can add cost, of course, but as we raise the floor through the Toronto Green Standard, the business case for the baseline scenario becomes less and less carbon intensive. So we're starting to see as an evening up of costs for low carbon systems at the district scale versus low carbon systems at the building scale. Again, you need a lot of density to make district energy work. You need size, but where you have that, district energy can make a lot of sense to decarbonize cost effectively. So now I'm just going to end last couple slides on something we've, I think in the next webinar in the series, you'll probably talk a lot about this, but I just wanted to maybe set the table a little bit. There is an opportunity for district energy systems at the small scale. Everything I've showed you so far really is large scale projects. And this is some context. So what these three graphics, what these three bar graphs show, and I'll put the link in the report before I share this, what they all say is that ground source heat pumps are essentially more effective than air source when it comes to reducing demand on the grid. Kyle at the beginning mentioned that air source heat pumps can have significantly high peak demand during cold times. This is some modeling that shows that, and it's all for Toronto. And you can see that on the far left, almost a 60% reduction in peak demand by doing ground source heat pumps at a single family home scale. The image in the middle basically says for the system as a whole, the electricity system, you're getting like 40% less cost by essentially having ground source heat pumps compared to air source heat pumps. The problem is on the far right, what you see is that the cost premium for the equipment is significantly higher, especially for single family homes, can be up to 60% higher. And that makes sense. You have to drill holes, you have to install pipes. You even need to have the space to have the drill rig there. So there's this issue where there's benefits in terms of cost for the whole system, but the capital cost for the individual is high. And that is where district energy comes into play. If you can spread those costs out over many people, now we're talking in terms of that's economies of scale. So really to enable small scale district energy, you need a large rate base. You need thermal grid to look more like the electricity and the gas grid. More customers means less fixed cost per customer. We need longer amortizations. Like 20, 25 years is not enough to recover the capital costs for some of these really ambitious projects. We need, again, utility type amortization periods, 40, 50 years. And then we need aggregation. Complexity is a challenge for district energy, and the more individual owners you have, the complexity increases significantly. When I said that the threshold for district energy is like 1 million square feet, that's 1 million square feet on one site. So you can imagine if you're dealing with hundreds of homeowners, like that really increases the complexity. So you need to aggregate. You need streets, neighborhood scale, not individuals, I think, to attract partners. And so all of this points to essentially some form of utility reform that makes district energy look more like the traditional utilities, I think, to truly enable district energy at smaller scales, not just for large buildings. Having said that, it's not going to be easy because air source heat pumps are getting better. I'm a believer that there will be solutions to reduce the peak demand issue. And I think there's an opportunity for both, and I would like to test this out. But right now, without that reform, it's going to be tough to attract, I think, the actors, especially because it's kind of easy today for most people to go and get a heat pump for their house if they want it. So that's at a high level the summary, and we can spend some time discussing it. I think it's important to understand that probably for the next webinar as well, where you'll talk a little bit more about with an expert on this. So that's it for my presentation. Again, I will update it to make sure you have all the right links. And happy to take questions. My contact information is there if anybody wants to follow up with me afterwards. Yeah, thank you.
Wow, thanks so much, David. That was excellent. Really fantastic overview there. So we have a couple of questions in the chat coming in already, and audience, feel free to post your questions. One from Isabel Varela was asked, should be an easy one. The Hotel X, when did the operation start there with the district energy?
Oh, it was completed only a few years ago. I think it was like 2019, 2020 that it was actually construction was completed. Now, we were providing construction heating and cooling before then. So technically it was operating, what was it, 2018, I think, but it really didn't reach full capacity until the hotel was occupied, which I believe was around 2020.
Thanks.
Mm.
A question from Aidan Sweeney. Is there specific technology to tap into wastewater heat, or is it simply a heat exchanger?
So it's a heat exchanger is a part of it, but yeah, it is there's more to it. So in the case of the Toronto Western Hospital project, the big piece of equipment is the wet well. That's the piece of equipment that connects with the sewer, and that is where essentially the sewage is lifted and sent to the heat exchangers. So that wet well, though, is a very large, complex piece of equipment because it has to deal with raw sewage. And so there's essentially processing equipment that screens out large stuff that flows through the sewer, which can be shopping carts and bicycles and all kinds of stuff. But then there's also equipment that grinds up some of the smaller stuff so it doesn't clog the heat exchanger. So there are pieces of equipment that are not necessarily part of the energy recovery, but they're important to ensure that the system maintains operations well. And it's very specialized equipment. In fact, the equipment we're getting from a company called Huber, they're like almost a 200-year-old wastewater and water company from Germany. And so there's very specialized equipment that is critical for the system to operate well. And then the other part of the equipment are the heat pumps too. And there's a large, in fact, I don't show it in the slides, but there's a building at the corner of Bathurst and Dundas that used to be a bank. That is now where the heat pumps will all be located. And so those are the main components: the wet well, the heat exchangers, and the heat pumps.
Great, thanks. I really appreciate the audience answering some of the questions, but this one I'm going to ask because I think there might be more to it. So from Ken Sharat, is provision being made for district energy in the construction of the new Ontario line and the replacement of water and sewer lines in the city? Can the pipes be inserted now to be used later? And I would maybe add to that, there might, if there aren't contracts and demand, is there a way that we can take advantage of that construction?
So the short answer is yes, it's possible. No, it's not being done. The challenge we have, so if a lot of infrastructure is being installed along with transit. In fact, we could think of district energy like the way we fund transit, which is you're building for a public good. In fact, transit never pays for itself. If we looked at district energy as something that didn't have to pay for itself, we could install all of the infrastructure as well. We could essentially fund it from taxes, and then you basically treat it as a public service. You don't worry about earning a profit or even recouping your costs. You just want to provide low carbon energy to all of the developments along that line. That's a possibility, but that's not what's happening now. Because we are primarily relying on private companies, they can't pre-install infrastructure and then wait for a long period of time to get that revenue back. Essentially, it could be a long period of time really before any of those transit-oriented communities are demanding heating and cooling. So you could have, it's just not palatable for these private companies to operate that way. Their shareholders, I mean, it's just not how they operate as a private business.
Question from Mike Green. Are any possibility of using waste heat from subway stations as a source?
Yes, and we've asked the TTC and they very quickly told us to politely go away. Yeah.
Yeah, I heard that there was the London, UK has a pilot or system there, so it can be done.
Yeah,
but
the Bun Hill system in the UK, it's totally doable. Sometimes there are particular challenges depending on the design of the system, and it's not easy. It is doable here, but I think TTC, it's their business. They were concerned about some of the complexity with trying to do that in Toronto subway stations.
Okay. I think you kind of answered some of this in the presentation. Question: does the City of Toronto have the ability to encourage or aid new companies or utilities to enter into the thermal energy business and have access to the public right-of-ways?
Yeah, so I mean, any company really is able to access the public right of ways. There's a process for it. It's not, they have the same ability to access the public right of way. The process will be slightly different for the regulated utilities versus the unregulated ones. The bigger issue is more on the cost. And we actually heard this at council this week, where Councillor Sachs moved a motion trying to essentially level a playing field between, for example, Enbridge and these utilities. Enbridge as a utility that's regulated, they have the ability to largely access at no cost the public right of way. Big difference for a lot of these unregulated utilities. They don't have that, and so they have to pay for it. And unfortunately, that can add cost to projects that are already challenged, especially if they're trying to truly decarbonize. So they both have the ability, and the city does help with that, but it's not necessarily equal.
So we have a question that's fairly lengthy that I'll ask the end part and then I'll go back and read the beginning. Why the light touch from the City of Toronto? Shouldn't the city be building, owning, and operating these networks? And then now I'll read the first part. Given that the city, number one, built N-Wave, two, builds and operates pipe with water, water and sewage, three, the city owns parks, roads, and sidewalks. The city has access to low-cost debt. Thermal networks are unregulated. District energy systems best benefit from economies of scale. And maybe I'll skip the rest. So why not more from the city? And also I would maybe couple with that, Markham has a municipally owned utility. Maybe you could add, put those two together.
Yeah, so it's again in this, where should I start? Like, I talked about ownership. There are benefits to being an owner, and again, you have control. You can choose to, for example, subsidize the upfront costs to make sure that, if you want affordable heating and cooling, like we do with housing, that's a choice you can make if you own it. You can subsidize the cost of that utility, and people can get heating and cooling for, what they less than what they would pay if they were dealing with a private company. So we can do these things, but like with housing, we do it because there's like strong political demand to, there's a housing crisis, right? On the energy side, I don't necessarily see the equivalent. Like there are definitely some people who live in energy poverty, but for by and large, what we're finding is there is a business that is viable here, and it's something that we don't have to do necessarily because we don't necessarily see that gap. Whereas with affordable housing, only government can provide it or pay for it. And so, but I think that the challenge is one of politics. Like we pitched this to council so the Etobicoke Civic Center project we are doing with N-Wave. We have a joint development agreement. And when we pitched some kind of relationship with N-Wave, we went through the different options, including not partnering with N-Wave and using them just as sort of a general contractor. Council decided they didn't want to take that risk of being in that business, that it's not our core, we shouldn't focus on it. Which again, there's analogs to housing, right? The mayor, you might have been hearing about this new public builder model, but she clarified recently, we're not going to be the builder. We'll be the developer, but not the builder. And so there's always a role for the private sector. Question is like, to what degree? And you can definitely make the argument that we should be treating this as a public service, but that's not the direction that council has given us at this moment. It could change, but in my opinion, I don't quite see that forcing function yet. That thing that says this is not working to decarbonize. We need to take a different approach. I haven't not yet seen that.
Question from David Wang. Once a large district energy system is built, can existing older buildings be retrofitted to expand the system in the surrounding neighborhood?
Yes, and it has happened. N-Wave has connected to some existing buildings. It's complicated because it's not so much about getting the pipe to that building. It's more about, is the building compatible? So, most buildings have equipment in the rooftop. So first thing you got to do is get that pipe, all the way up to like the district energy pipe. So you got to run it up to the penthouse. So imagine trying to find space in what is already a small building core for a large riser pipe. You might have to core through the individual floors in the garbage room. Like the Toronto Western Hospital wastewater project, half of the cost of that project is the work done inside the hospital. Like it's not just the civil works to install the wet well. Half of it is the retrofit cost for the hospital. And so the answer is yes, but it's very economically challenging. It often requires, you need a scenario where it's almost easy to connect that building. And so we don't see a lot of it, but it's definitely possible.
Great. Question from John Stevenson. Might there be a zero emission standard coming for existing buildings?
Yes, and it's public knowledge at this point. The city is working on what it calls emissions performance standards for existing buildings. So in crude way, you can think of it as the Toronto Green Standard for existing buildings. It won't have necessarily all of the requirements of the TGS, but in the title kind of alludes to this, emissions performance standards. It will likely set some kind of emissions cap for existing buildings. And if you don't meet that, presumably you can be penalized. So there's going to be compliance and enforcement. We are years away probably from it being implemented. The team that's working on it, my colleagues, are just now thinking about the public consultation, what the policy might look like, how to roll it out. It's a huge endeavor because it's going to affect the whole population of buildings of the city of Toronto. It's worthwhile doing because really that's where most of our emissions come from. I think the important thing to note, we're not alone. New York City did something very similar. Metro Vancouver has something. There are other North American jurisdictions and of course in Europe. But so the answer is yes. I don't know how long it will take to get it to zero because I think a lot of these things get phased in. But I think what you'll see, like with any sort of regulatory signal, is that the movement will happen ahead of when it's a minimum requirement. The EV mandate by 2035, you're going to see a lot more uptake of EVs well ahead of that. And so I think it's more setting the signal. And then the key part is how the city helps people get there, because we don't want this to be punitive. And so it will be paired with a lot of programs and incentives to make sure it's achievable.
And that's a good segue into the next question. Lee Adamson, are district energy ready buildings coming in the building code? So all new buildings are ready?
I highly doubt it. I don't have any advanced knowledge of the building code. I mean, other than it's not going to be in this next version, which I think we're supposed to see in March, and or at least the harmonization. So I don't. It's possible. I don't think so. I would be surprised to see district energy ready requirement. The problem is like it takes judgment to determine where it makes sense. The building code applies to the entire province, but not every building, actually very few of them should be district energy ready. And so what I'd prefer to see, and I mean, it's unfortunately also not happening, is the building code look more like the elements of the Toronto Green Standard, where they were more aggressive on carbon targets and energy. That will drive district energy where the economics make sense, instead of taking the approach of specifying where we think it should happen.
Question from Tyler Hamilton. Is there a role for an Enbridge gas to play here? They have the scale and resources to do this in neighborhood. And is the OEB looking at regulating this and creating a rate-based structure?
Enbridge has applied at least on one occasion to essentially have thermal energy be part of their regulated activities. And so far, the OEB has not granted them that. But each time they bring it up, it seems that they're closer to doing something like that. In the last, prior to this recent rate filing, where they talked about integrated regional or integrated resource planning, this conversation always comes up about what is the role of Enbridge on the thermal energy side. Should they be allowed to make thermal energy supply, not gas, but thermal, part of their regulated activities? And the OEB is treading they have to be very careful, because there is now an active market of private companies that are providing thermal energy. Giving Enbridge, making it a regulated utility space, it would you're either creating that thermal energy monopoly, which you kind of wonder what happens to these other businesses, or you have to give them the same ability to level the playing field. And so I don't know where that's going to end up. But I do know that, yeah, if we want district energy at a much larger scale, I mean, I do think you have to move it more towards looking like the traditional utilities, for the reasons I said earlier, which is, scale, aggregation, and amortization periods. So it's possible, and like I said, maybe the most hopeful thing is that each time Enbridge goes to the OEB to discuss integrated resource planning, see more and more amenable to it. What they've done in lieu of that, Enbridge does have their program called Sustain, which is essentially their version of the energy developer. It's unregulated, and they're out there offering, the same type of things, geo exchange, district energy, wastewater, on similar terms as these other companies. And so they're competing. Early days for them, but that's a good sign. It's just that there's no sort of difference from the other companies that are in terms of the business model, and so it's not going to quite solve that issue of scaling it to like lower density neighborhoods.
So I'm going to go to a question from Dawn, and then we're getting close to the bottom of the hour there. So question from Don Booth: what leverage do we as community groups have in pushing district energy to happen faster? Where can we push?
Yeah, I mean, I think like your advocacy is helpful, and I think it's primarily to the province. As we've seen, the province will dictate what the OEB should and should not do. But I would hesitate to say you need to advocate specifically for district energy. I mean, I don't know, our approach tends to be technology agnostic or distribution system agnostic, and we let the economics determine where it makes the most sense. So I think the most important advocacy is, for decarbonization of buildings, which frankly is the area where the province does have a lot of work to do, in my opinion. But we're not seeing that. They're doing a lot on electricity generation, sort of electrification in general. But really what district energy thermal networks do is displace natural gas. And unfortunately, I think they have a different point of view on the role of natural gas in buildings. And so your advocacy there would be most, I think, effective. And really that's where, like, to create the change, whether it's building code or OEB reform, it does come down to, the political will to do that. And so anytime the province puts forward either legislation, which in fact they are, Bill 165, opportunity for people to comment on, there are going to be, that's where I think your advocacy is most welcome. As individual homeowners, like, look, in some scenario, if you can convince everybody on your street to do a large enough geo exchange based district energy system, there may be a willing actor out there and enough subsidy to kind of make it work. But I do think for now we're in a mode where we need to create sort of the market for businesses to offer this as a service, until such time as council tells us that we as the city need to take a more direct role in these projects.
Thanks very much. And with that, I'm going to hand it over to Kathy to kind of wrap.
Well, thank you. Thank you so much, Rose, for that, presenting those questions. Thank you. Once again, we'd like to thank David MacMillan for coming to talk about thermal energy networks. It's been an amazing and informative session. David, would you like to make any closing remarks?
Honestly, I'll just say again that I'm happy to engage with anybody who maybe we didn't get to your questions, or maybe you just want to engage. I'm totally open to that. I will share the I'll share it with the organizers, who can then share the presentation, and my contact info will be there. So yeah, don't hesitate to connect anytime.
That's excellent. Thank you so much. Before we depart, I want to thank our stellar organizing committee members, Don Booth, Rose Cudluck, and Kyle Duncan, for putting together this series. The series will continue. We invite you to join us on Thursday, March 28th, with John Stevenson, director from the Boltzmann Institute, and Peter Tabbins, MPP for Toronto Danforth. And they will continue this discussion about district energy. So thank you so much. Thanks again, David. Thank you to everyone for coming. Thank you.
Take care.
Bye for now.